Hello everyone. Thank you for joining us for our next session, which is entitled macOS Endpoint Security 101. Before we begin, I'd just like to pause for a moment so you can view our forward-looking statement. This will also be available in our resources section if you'd like to do a detailed review. So, welcome again to our session on macOS Endpoint Security 101. My name is Mark Walker. I'm based in the UK and I work for Jamf as a Security Solutions Lead covering the EMEA regions. I'm also joined today by my colleague Matt Woodruff, based out of the US. Matt works for Jamf as a Worldwide Security Solutions Lead covering all other regions.
And hello everyone. And I agree with Mark. Thank you so much for joining us today. We will be discussing in this session Mac endpoint security, but for two different audiences. One is for the Mac admins that don't really know the InfoSec world of an attack and how malware is distributed. We will also be hitting on the InfoSec teams that are very well aware of how Windows operating systems are attacked and what those differences are on macOS. The anatomy of an attack happens in various formats. We will go through one example and then describe a few others. For the example that we'll have today, you have a macOS device. It's pretty healthy. You just got done deploying it. The end user is being productive, but they happen to receive a very unique email. As you might have guessed, this particular email is a phishing email. This user is lured to a malicious site that is prompting them to do something that they perceived is urgent, needs attention. And as they possibly click around on various aspects of that screen, that particular site has caused them to download a malware program. Now that they have possibly taken the steps that the site led them through, the device is now infected with the malware. This is just one example of many that exist for how an attack can happen on any endpoint in your environment. When you deal with an attack, it can be disseminated through various networking components. That way it's propagated through various peer computers. We've shown here how an email can be distributed throughout an entire organization, luring them to malicious sites. You also have various websites that might have particular malicious code or downloads, or the URL seems very unique and similar to other websites that exist. And then you also have file sharing techniques where the files or the malware programs are distributed through various file sharing networks or file sharing within the organization itself. But think about this. When a Mac is in fact compromised, there are multiple means to distribute and disseminate that particular malware. Because once it's infected, you will now have servers, network devices that are starting to distribute it all over your company. And more prevalent for today's terms is remote workforce that happens to have Macs introduced to home network environments that have other devices on that home network in which it can distribute or receive from home networked devices.
So we know that many of you will have Mac in a mixed environment where there is also Microsoft Windows. And this being a Mac session, let's briefly talk about Windows and common techniques that are used to attack that operating system. These include, amongst many others, registry keys. Registry keys can be used to, for example, remotely query the registry to see if any remote access tools are installed. And with that information, a malicious actor could leverage those tools and spread further throughout an environment or find a route to more valuable and interesting systems. Service execution. So with service execution, attackers may abuse the Windows Service Control Manager to execute malicious commands or payloads. And this can be done either by executing a new or a modified service. BIOS attacks, built into computers, enabling the configuration of the hardware. Obviously, this used to be known as BIOS, but now there's a newer standard called UEFI, which provides this. And an infection in the UEFI means the attacker has full control over the device and can potentially compromise other devices on the network. And since BIOS routines are run when the computer is booted, any malware executed at that stage takes complete control of the computer, even before the operating system is loaded. With PowerShell, we're increasingly seeing the introduction of fileless malware, where an exploit is achieved leveraging legitimate Windows tools, which essentially makes them undetectable by signature-based detection engines. PowerShell provides unprecedented access to a machine's inner core, including unrestricted access to Windows APIs. And it offers the benefit of being an inherent part of Windows that's completely trusted, so the commands it executes are usually ignored by security software. It's very difficult to differentiate between malicious and legitimate use of PowerShell commands. DLLs are used in Windows as part of how applications function. Instead of developers reinventing the wheel every time they write code, they instead utilize DLLs, which have been written to provide specific functionality. Applications call DLLs as and when they need them, so they can effectively be considered as executables. Hence, you can see that if an attacker is able to hijack a DLL and perhaps replace it with malicious code, then it becomes quite simple to compromise a user's machine. With access token manipulation, the intention is to grant a malicious process the same permissions as a legitimate user and to pretend to be a process started by that user. This may increase the capabilities of the malicious process or reduce its probability of detection. And access tokens are designed as a security feature on Windows. Their purpose is to describe the exact permission that a particular user should have on a computer. But they can be manipulated to provide a higher level of permission than is desirable. Attackers use this feature by using specific API calls to gain elevated access to the system. And finally, Windows management instrumentation. In the same way an administrator uses WMI to query metrics and execute code, a hacker can use it to silently and instantly run malicious code across an entire network of machines. WMI also allows for persistence by auto-running programs stealthily on startup or based on specific events. WMI can't be uninstalled, but it can be disabled. However, doing so impairs and limits what an administrator can do, such as update software across multiple machines. For these reasons, it makes an excellent way to attack Windows. So we can see that there are a number of common techniques that can be used to attack Windows. So why is this relevant? It's relevant because Windows malware is very different to Mac malware. And to talk a little bit about the methods of attack for Mac, I'm going to hand over to Matt.
Thank you, Mark, for describing those unique variables and examples of techniques, tactics, and procedures used on Windows operating systems. But what you're going to find with macOS is that there are going to be some uniqueness to malware attempts on macOS. One of the most common is for a malware program to stay persistent. Let's say you quit the app. You even log out, or you restart or shut down your Mac. Upon reboot and log in, you'll find that that malicious application will want to start back up. One of the methods to complete that persistence technique is to build a launch agent or launch daemon. Again, unique to macOS. With the underlying architecture of macOS built on a Unix variant of mock kernel, there are some unique vulnerabilities that are related to that. Some examples of Unix manipulation that can occur on macOS is hijacking the PAM-D module for various authentication techniques, or possibly editing the sudoers file, the utilization of shell or bash scripts, or the setting up of cron jobs. All of those can be attempted on macOS. The last technique, that's common across both Windows and Mac, has actually become more of a targeted approach on Macs these days because of all of the new security controls introduced by Apple. macOS now enforces that a user approve every process that wants to access different parts of the OS, like the file system, hardware devices, or even networks, in order to validate to the user that it should be accessing those components. Well, this has caused many applications to utilize very unique strategies for phishing and spear phishing Mac users. There are many more that we find when approaching techniques, tactics, and procedures on macOS. This is an example of all of the different categories, or otherwise known as TTPs, techniques, tactics, and procedures, that the MITRE Corporation has found on their attack matrix for macOS. Therefore, this is just an example of multiple methods of infiltrating or building malware programs for macOS. The great news is Apple, in both hardware and software, does in fact have built-in tools. Let's go through some examples of where this can actually be incredibly helpful as you introduce Apple devices to your environment. First is a silicone chip on each Mac that has been introduced in the T1 and now the T2 chip that has the secure enclave. It provides a foundation for encrypting data at rest, the secure boot process on macOS, and handles biometrics. This ensures that the lowest levels of the software aren't tampered with and that only trusted OS software from Apple loads at startup. App signing and notarization is another form where Apple requires in macOS Catalina and Greater that every app be signed or notarized in order for it to run on macOS, therefore limiting the amount of malware introduced to the macOS platform. SIP, or System Integrity Protection, helps protect the boot, loader, and the kernel against malicious writes from within a running operating system. macOS also includes a built-in firewall that is fully configurable by an MDM management server. Packet filtering also exists within macOS but many critical network shaping tools are getting diverted to the network extension framework moving forward.
Thanks, Matt. So in addition to those tools, macOS also comes shipped with the following built-in tools: XProtect, MRT or Malware Removal Tool, and Gatekeeper. And very briefly, the purpose of these tools is as follows. So XProtect is Apple's own signature-based anti-malware solution. It sits quietly in the background within macOS, and most users and even some IT teams don't realize it's even there. The system uses Yara signatures, which Apple updates regularly. And Apple monitors for new malware infections and strains and updates this signature database automatically, independently of system updates, to help defend Mac computers from malware infections. XProtect automatically detects and blocks the executions of known malware. And in macOS 10.15 or later, XProtect checks for known malicious content whenever an app is first launched or has been changed. MRT, or Malware Removal Tool, is an engine in macOS that remediates infections based, again, on updates automatically delivered from Apple. Apple issues these updates to MRT to remove malware from any impacted systems that are configured to receive automatic security updates. And when MRT receives updated information, it continues to check for infections on restart and login. And finally, Gatekeeper. In an ideal world, Apple would like users to install software from the macOS App Store. And the reason for this, amongst others, is that Apple will have security checked the software for the presence of any malware. When a user installs Mac apps from outside the App Store, macOS uses Gatekeeper to check the developer ID signature and verify that the software is from an identified developer and that it hasn't been altered. By default, macOS Catalina also requires software to be notarized, so that you can be confident that the software you run on your Mac doesn't contain known malware. And notarization, for those of you who are not aware, is basically a process whereby Apple scan the software for malware. And finally, before opening downloaded software for the first time, macOS requests from the user permission to make sure that they are not being misled into running software that they didn't expect. macOS offers different methods for endpoint security tools to be built. Most common for the longest time were kernel extensions because of the unhindered access to the macOS kernel. Most endpoint security tools started on the Windows platform, then ported that same tool over to the Mac. And this has caused tremendous headaches to Mac users on performance and is the leading cause of kernel panics. Tools in this space include antivirus, endpoint detection and remediation tools, data loss prevention, CAS-B solutions, and so on.
Now, the current state of endpoint security tools on macOS is actually in a transitional phase. For Apple is leading the charge in getting one out of the kernel. They made this announcement in their Worldwide Developer Conference of 2019 in session 7.02 that kernel extensions within macOS will no longer be allowed. Apple has provided new frameworks for endpoint security tools to use called system extensions. A few endpoint security vendors have started to properly build on these system extensions using the endpoint security and/or network extension frameworks. Jamf is one of those leading this charge with an endpoint security solution called Jamf Protect.
Apple made the announcement in this year's virtual WWDC that Big Sur will make it harder to install kernel extensions and even limit their capabilities. If your current endpoint security tool is not supporting the new frameworks by this fall, when Big Sur releases, you may get notified with one of two statements. The first is that your endpoint security tool is testing support of Big Sur. And this is fine, but for you as a customer, does it mean that you have the full support of your vendor? The second is that your endpoint security tool suggests that you don't upgrade to Big Sur or purchase any new Apple devices that come with Big Sur, because they're still in the process of testing their product. This leaves you as the customer in a position where you have a huge security risk. Security baselines. When given the need to protect your sensitive data, you might get overwhelmed with all the different settings that exist on your endpoints, especially when you are using a multi-platform environment. And all of these settings need to be turned on or off so that data can't accidentally leave your corporate devices. There are many organizations around the world that have taken the task on of collating this information, and they publish all of their guidance inside security benchmarks that lay out different controls to enable on each endpoint. Security benchmarks are a common set of best practices for the secure configuration of a target system. And benchmarks help organizations monitor and assess their security baseline to determine compliance and cybersecurity maturity across their endpoint fleet. Examples are CIS, NCSC Cyber Essentials, ACSC ISM, and NIST. And these lists get pretty exhaustive because they need to present all the options necessary for you to make an informed decision on what needs to be disabled or enabled to prevent data exfiltration.
So what's next? We do have some goals for you as you continue this journey. First and foremost, research. Research on your own. What are the endpoint security solutions out there doing? Are they properly protecting macOS? Do they have the right research backing them up? And more importantly, do you properly understand the different techniques, tactics, and procedures that people, specifically malware and hackers, go through when looking at macOS? One of the additional abilities for further research will be to scan the QR code in the upper right-hand corner, which takes you to downloading our Filling the Gap white paper on jamf.com. As you can see on the text on your screen, please review the following virtual JNUC 2020 sessions that we have focused on the Jamf Protect product and sessions related to Jamf Protect and Jamf Pro integrations that we have. And with that, we'd like to thank you so much for listening.